According to the cloud now. Where we're going to pick up is where we left off in section 7.5. We were talking about multiplying and dividing radicals, and we did a whole bunch of examples of multiplying, and we never got to any division examples. So here we are, we're ready. It's time to divide. I'm going to move this back a little bit to get a little bit more of a fuller picture of the board. There we go. That's what we want right there. Okay, so 7.5, we're going to continue talking about multiplying and dividing radical expressions. So we talked about multiplying, we did that. The end here with division. The thing about division is there's not really any division in dividing. So what we're going to do is a process. So for instance, if I would give us something like this, 3 over the square root of 7. So this is a problem that involves division, the radical. The 3 is not under a radical, the 7 is, so I can't do anything with those numbers directly. So what division becomes is more of a simplification process. What we want to do is we want to not have a radical in the denominator. So this is called, mathematically, this is a process that we're going to talk about called rationalizing the denominator. There are two situations of rationalizing the denominator that we are going to talk about. Okay, you need to know how to do both of these for the test that we're going to have in a week. So they'll both be on it. So the first type is when I just have a monomial. A monomial. Mono means one. If I just have a single term in the bottom. Well, here's what you're going to do when you have to rationalize a fraction that has a single monomial in the bottom. You're going to do this. You're going to multiply by something that gives me a perfect square under the radical. And in this case, that is going to be the square root of 7. The reason I'm picking the square root of 7 is because 7 times 7, that's going to give me 49 underneath the radical. When I multiply the denominator of a fraction by something, I have to multiply the numerator by the same thing. So I'm going to multiply the top by the square root of 7. Now here's what I've got. In the top, I've got 3 times the square root of 7. This 3 is outside the radical. The 7 is under. Bless you. So I cannot do anything with those two things. So 3 square root of 7. In the denominator, the square root of 7 times square root of 7, they're both under the radical. That's the square root of 49. And the good news is I can simplify the square root of 49. So I have 3 square root of 7. When I do the square root of 49, that is equal to 7. No more radical on that. Once you've taken the square root, you no longer need the radical. Can I divide? Can I cancel these two 7s right here? Why not? Perfect. You cannot. That was the answer, and that's the correct answer because this 7 is under the radical. This 7 is outside the radical. So they are different things. You cannot go any further with that problem. So I'm going to give you 1 or 2 of these situations where you have a monomial in the bottom and you have to rationalize the denominator. So here is yours. I would like you to do 9 over the square root of 5. Rationalize the denominator of that, please. What am I going to multiply the top and the bottom of this by? Not, I think you mean the right thing, but I want you to say the right thing. Not just 5. I can't just multiply by 5 here. Square root of 5, yes. I think that's what you meant, but I just want to make sure we're using the proper words and say what we're meaning there. It has to be under the square root. Otherwise, you can't multiply these things in the bottom. So in the top, I have 9 times the square root of 5. The 9 is not under the radical. The 5 is, so they cannot be multiplied. Square root of 5 is the square root of 25. And then my last step is I have 9 square root of 5 in the top. Square root of 25 is 5 in the bottom. I've got 2 more examples we're going to do of rationalizing when there's a monomial, a single term in the bottom. Here is the next one. I would like you to please rationalize this denominator. That's what dividing radicals is rationalizing denominator, so you are doing it. So I would like you to do 3 over the square root of 6. What am I going to multiply the numerator and denominator by at this one? That's indeed true. Thank you very much. Great answer. Love it. So in the numerator, I've got 3 times the square root of 6. The denominator is the square root of 36 because 6 times 6, they're both under the radical. So I can now go ahead and do this. Square root of 36 is 6. Now I can do a little reducing on this one. Okay, that was my purpose on this example. Because outside the radical, both of these are outside. I've got a 3 and a 6 outside the radical. So 3 goes into 3 one time, 3 goes into 6 2 times. So I've not violated anything I've told you about radicals on that particular thing, because both of those numbers were outside the radical. All right, here's one more problem with a monomial in the bottom. I would like you to rationalize this denominator. Square root of 7 over square root of x. All right, what are we going to multiply the top and the bottom of this one by? Perfect. Yep. We multiply by whatever gives us a perfect square in the bottom. Okay, it's always the case. So in the top now, oops, that's an X. It looks like a backwards Y. In the top, both of these are under the radical. So I have the square root of 7x. That's great. On the bottom, I have square root of x, square root of x. That's the square root of x squared. And what that becomes is square root of 7x in the top, square root of x squared is x in the bottom. Notice our goal in every one of these. Every time we have no more square root in the bottom. That is our goal when we divide and we have radicals. All right, so the last thing from this section, 7.5, is this. The other situation that you might be asked to rationalize the denominator is if I have a binomial. So 5 plus the square root of 7 in the bottom. Now, I don't know if you remember, in class last week, it was a long time ago, 5 days ago, we multiplied two things together, and I called them conjugates. And what that meant is the only difference between the two things was the sign in the middle. And the good thing that happened for us is when we multiplied, all of the outers and inners stuff canceled out. There was no more radical left in what I did. This is the time when we get to apply it. When you have a binomial under here, what you're going to do so that we end up with no more radical is you are going to multiply by the conjugate of the denominator. Multiply by the conjugate of the denominator. All the conjugate is, all this word means is whatever you have in the denominator, whatever binomial, change the sign in the middle. So 5 plus 7x, the conjugate is going to be 5 minus this. I said 5 plus 7x. I don't know why I said that. Let me try again. 5 plus the square root of 7. The conjugate is going to be 5 minus the square root of 7. In the top, you're going to do the same thing. 5 minus the square root of 7. Once you've done that, it's just a multiplication problem. So it's just take you a minute or two to go through the busy work of this. In the numerator, I'm going to distribute. So I've got 4 times 5. 4 times 5 is 20. And then 4 times negative square root of 7 is negative 4 square root of 7. I just distributed in the top. In the bottom, we did a bunch of these problems last time when we were together. I am going to go ahead and FOIL these two things together. My first, my outers, my inners, and my lasts. So hopefully you're getting better and better at doing this because we did a whole bunch last week, and hopefully you did some homework. So my first 5 times 5 is 25. My outers give me negative 5 square root of 7. My inners give me positive 5 square root of 7. And then my lasts are negative square root of 49. There's nothing else to do in the top. It's waiting patiently for the end of the problem. Here's why you multiply by the conjugate. If you use the conjugate, then these outer and inner term right here, they should always cancel. So they do have a negative 5 square root of 7, a positive 5 square root of 7. Goodbye. What's the square root of 49? 7. So this is 25 minus 7, and that becomes 18. And notice I don't have any more radical in the denominator. That's exactly what I want. There's one more little thing that I can do in this problem. I included everything that you're going to encounter in one of these problems in my example. If I'm going to reduce, remember I have to be able to distribute. Is there something in common to all three of these values right here? 24, 18. Do they all share a common factor? What was that? 2. Yes, they're all even numbers. So I can reduce all of these by a factor of 2. So I'm just going to write a little note to you. We're going to reduce by a factor of 2. And so when I do that, 2 goes into 20 and leaves 10. 2 goes into 4 and leaves 2. And 2 goes into 18, leaves 9. That's fully reduced, and it's done. You can only reduce when you can distribute, when it's done with all of the terms. Okay, so not just one pair or the other, but it has to be all of them. All right, I've got 2 examples. You're going to do this 2 times, and then we are going to be done with section 7.5. Heading to the finish line. Here's a problem for you. 5 divided by 4 minus the square root of 3. Just as a nudge, we're not going to work the problem just yet. What's the conjugate that you're multiplying by?
4 plus.
Perfection. Great job. 4 plus the square root of 3. I'm going to get started on this multiplication. If you have any question, if there's anything that's unclear to you, let me know. On the test you're going to take, I'm going to put at least 2, maybe 3 of the rationalizing when the denominator is a monomial, and I'm going to put a couple like this. If you can do this problem, you're sitting pretty, okay? If you're not following this problem, you should ask me a question, okay? Because it's going to look just like this, except different numbers. So in the numerator of this problem, I'm going to distribute the 5. So 5 times 4 is 20. And then 5 times square root of 3 is 5 square root of 3. In the denominator, first outers, inners, lasts. So my firsts, 4 times 4, give me 16. My outers, 4 times the square root of 3 is plus 4 square root of 3. My inners, negative square root of 3 times 4 is negative 4 square root of 3. And then finally my lasts, negative square root of 3 times positive square root of 3 is negative square root of 9. So now all that remains is a little bit of simplifying, and we'll see what happens. So first thing we notice, the first thing that should happen every time we do this is these two inner terms should be opposites. Okay, that's why we multiply by the conjugate and we change that sign. These go away. And then the square root of 9 is 3. So 16 minus 3 is 13. There is no factor that is in common to all those terms, so we are done with that problem. That is it. I've got one more that I'm going to have you do. And this is going to end section 7.5 for us. So please do this. Square root of 3 plus the square root of 7 is in the numerator. And then square root of 5 minus the square root of 2 is in the denominator. Don't worry that the numerator is a binomial. It just means you're going to have to FOIL in the numerator as well, but it doesn't change anything else about what you're going to do. Just a nudge in the right direction. What is the conjugate that you're multiplying by in the denominator? Perfect. Square root of 5 plus square root of 2. All you're doing is you're changing that sign in the middle. That is it. There's nothing more complicated about the conjugate. It's just a fancy word. All right, so I'm going to get started multiplying. Again, this is the last example. So if you got a question, bring it on. So it's just a whole bunch of foiling here. So in the numerator, my first square root of 3, square root of 5 is square root of 15. My outers, square root of 3, square root of 2 is square root of 6. My inners, square root of 7, square root of 5 is square root of 35. And then my last, square root of 7, square root of 2 is square root of 14. Here's what to notice. None of these numbers have a perfect square factor. None of these radicals will simplify at all. There's nothing to do. That's great. There's no like terms. Don't force anything together. That is it. The denominator, my first, square root of 5, square root of 5 is square root of 25. My outers, square root of 5 times square root of 2 is square root of 10. My inners, negative square root of 2 times 5 is negative square root of 10. There we have those opposites that we were looking for. And then last, negative square root of 2 times square root of 2 is negative square root of 4. We're just about done. It's going to take me longer to rewrite the numerator than it is to finish the problem. In the denominator, the square root of 10 and the negative square root of 10, those cancel. The square root of 25 is 5. The square root of 4 is 2. So 5 minus 2 is 3. And we're done. That's it. That's what is considered division with radicals, is this process called rationalizing the denominator. Just to summarize, rationalizing the denominator means my goal is to make the denominator something without any radicals. And we've done that every time.